Hello, my name is Bryce, and this is my channel Striving Intellect. And today we're going to talk about microplastics and nanoplastics that are located inside of our bodies and using lasers to locate said micro and nanoplastics. And right here, what we have is a couple visualizations of different micro and nanoparticles of plastic that are inside of the human brain, which is a pretty worrying thing. The idea that we have large amounts of nano and microplastics in our body and they cause health effects that are not necessarily good is a little bit worrisome. And there's also a problem with getting said micro and nanoplastics out of our body. But the first step is obviously to locate them. And it actually is estimated that we have 4,800 micrograms of microplastic per gram in our brain. And that is the equivalent of a plastic spoon worth of microplastic just in our brain. That's not counting any of the other organs inside of our body, which again is pretty worrisome. It doesn't seem like it's going to be a good thing that we have all of these plastics inside of us. But the article that I was really wanting to focus on is this one right here on discovermagazine.com, and it is titled "Lasers Could Help Detect Nano and Microplastics in Bodily Fluid." Learn more about the research project that's helping experts analyze the nanoplastics in the human body. From the food we eat to the air we breathe, microplastics and their even smaller equivalent, nanoplastics, are just about everywhere. And while the body may expel some of the plastics we've consumed, there are still plenty that linger in our blood and organs, leading to other health issues. Recent research as part of the FFG Bridge project, Nanovision, uses a new sensor platform that allows for a laser to be shown at clear bodily fluid. Through this process, researchers can now determine the size of the nanoplastics in bodily fluid along with their chemical makeup. With this new technology, the team hopes to one day determine if intraocular lenses, surgically implanted permanent lenses that replace natural eye lenses after cataract surgery, may contribute to nanoplastics in the body. Lasers versus nanoplastics. Harold Fitzik from the Institute of Electron Microscopy and Nanoanalysis at Graz University of Technology, along with an ophthalmologist from Graz, launched the startup company Brave Analytics and the FFG Bridge project Nanovision about 2 years ago. One of their goals was to determine what role nanoplastics played in ophthalmology, or the treatment of eye disorders. More specifically, they wanted to see if intraocular lenses released nanoplastics into the eye. The test for nanoplastics, the search team used a two-step method. The first step was to draw the bodily fluid through a glass tube that's part of the sensor platform created by Brave Analytics. The second step was to shine weak laser through the fluid or against the fluid's flow through the glass tube. When the laser contacts nanoplastic particles, it begins to pulse, causing the particle to speed up or slow down depending upon its size. From the velocity, the research team could determine the particle's size and their concentration in the liquid. It's a really good thing that we're finally figuring out some way to track down and find these different nanoparticles and microplastic particles. Obviously, the next step would be finding a way to maybe get these plastics out of our body. It seems like there are a large amount of negative consequences to having these things inside of us. And like I said, a study suggests that human brains may contain an amount of microplastics roughly equivalent to a plastic spoon. Researchers found that the average brain tissue contained about 4,800 micrograms of microplastic per gram, a concentration that roughly matches the amount of plastic found in a standard plastic spoon. This level is also significantly higher than what we found in other organs like the liver and kidney. And this is actually a graph showing the amount of microplastics in our body going up. And it seems like the study starts in 2016 and ends in 2024. And as you can see on all of these graphs, the line is going up over time. And usually for something like that, that's a bad thing. And they even have what looks like the amount of cases of dementia going up over time as well. And they have a comparison of both the liver, brain, and kidney. And again, it looks like from 2016 to 2024, the amounts of microplastics and nanoplastics in our body has gone up considerably. So it's always a good thing that they're able to find some way to get this out of our body, or even just identify it, because that would seemingly be the first step in actually extracting it from our bodies, if that is possible. So I'll go back and read a little bit more from this laser study. Here we go. Optofluidic force introduction. According to the study, this method is known as optofluid force induction and was developed by Christian Hill from Brave Analytics. Part of the process involves combining optofluidic force induction with Raman spectroscopy, a technique used to determine the mode of vibrations within molecules. In this case, Raman spectroscopy uses Raman scattering, a process that sees how light interactions with molecular vibrations. This happens at a different frequency than the laser. Through this, the research team can draw conclusions on the composition of nanoplastic particles. Here's a quote. Depending on the material of the focus particles, the frequency value are slightly different in each case, thus reveal the exact chemical composition. This works particularly well with organic materials and plastics. What the future holds. More research is still needed to determine the intraocular lenses could release nanoplastics into the body, either through general wear or exposure to laser energy. Either way, these findings will be crucial in optometric surgeons their future patients. Sorry, I probably butchered that. Besides using the laser on bodily fluids to test plastic compounds, this technology can also determine the amount of microplastic in drinking water, leading to a healthier bodies and water sources. Here's another quote. Our methods of detecting micro and nanoplastics can be applied to clear body fluids such as urine, tear fluid, and blood plasma. However, it is also suitable for the continuous monitoring of liquid flows in industry as well as drinking and wastewater. Again, there is a uptick in the amount of plastics that have been found in our body, and even beyond that, there's not necessarily exact correlation, but they do think that things like dementia are because of some of these micro and nanoplastics. I'm sure birth rates, cancer, I'm sure there's tons of negative correlations to having large amounts of nano and microplastics inside of our organs and blood. And any way of finding, or even better than that, actually getting these microplastics out of us would be a massive step in the right direction, because obviously we're not meant to have plastic inside of us. So I thought this was really awesome. I hope you guys did too. Please like and subscribe.